Hey guys, good evening. I'm coming to you live from my messy office. It's kind of my fault that it's messy, but so I apologize for that. But anyways, today we're doing a little bonus lecture. One of my favorite things that to talk about when it comes to circular motion. I know what you're thinking, right? Circular motion. That was last unit, and you'd be right. But I'm just now getting to it because I needed some specific materials, but I have them now, so we're good. We're golden. So today, what we're going to be talking about is this little thing called a gyroscope. It's basically a little spinny thing. It's kind of like a physics Beyblade, if you know where that is, alright? But all it is just a little disc that spins. Right, and it spins very nice, very well. Right, it's just a fun thing to play with, but it's actually a very useful way of showing some awesome circular motion physics. All right, so what you can do, there's this little pinhole, or this little hole in the top. You can't see it, especially because my camera's not focusing. There's a little hole in the middle, and what you do is you thread your string through that hole and then wrap it around. What that allows you to do is when you pull the string, it starts to spin rapidly. So here we go. Huh? Hear that? All right, and it does this really cool thing where as it's spinning, it balances, right? And it also travels round and round in circles, right? That's what's known as the precession of a gyroscope. And today, I kind of want to talk about the physics behind that and how it can apply to other things. It's very interesting. Let's get into it. Yeah, here we go. Right now, I'm trying to thread the little piece of string through there. Oh, man. It's really a pain. And I wish I could, oh, there we go, like this, and then you just kind of spin it up. I will use that later, okay? But it's actually really important to keep in mind that this object, as it spins, it also precesses around its axis, like that, okay? Now, to explain why that is, I'm going to break it down into an object that's a little bit simpler. This is a little DIY project that you guys can do at home if you want. It's kind of simple, but it's also super finicky. I was kind of lazy when I made it. It's a little off balance, but all it is I took a paper plate and then used like this Lysol thingy, put it on the paper plate, drew around it, and then cut out a circle. All right. On that circle, I took a little pencil eraser and super glued it on there. Okay. Now, what you got to do is take a pencil, preferably, at least I think, a mechanical one, sort of stick it on there, like so. Okay. And then forgive me because this might take a few tries, but what you got to do is you got to spin it. Oh. See, this is the finicky part. It's great when it works, but it's just a little irritating, right? But you're gonna spin it, and this is why you want to make sure that it's like really well balanced. I feel like the eraser kind of shifted around as I was gluing it, but you know, this is what we have right now, and this is what we're gonna do. All right, but you can spin the little disc like so, and it's gonna eventually fall off. But what I'm gonna do is I'm going to blow. So as I spin this little disc of paper, I'm gonna blow on the side closest to me, right? And it behaves how you expect it to behave, right? If I blow on this side, it's going to tilt towards me, okay? That's what's known in the physics world as a torque. A torque is basically a force applied to an object at a certain point that will cause it to rotate, right? So if I apply a force down right here, it applies a torque to the object and then it rotates around like the center point, okay? So I apply a torque towards me, it's going to lean towards me, right? Pretty simple, right? But now, if we start spinning it, you see that? I was blowing on this little thingy, and it went like this when it wasn't spinning, but when it was spinning, it actually tilted this way. It tilted to the side, right? Again, so we're going to try that again, and I want to see if you can catch it. Oops, that did not work. Gotta spin it faster. Look at there. All right, cool. And you can do that multiple spaces around. You can blow on the end nearest you, or if you were doing it, the end away from you, and you'd actually see it tilt this way, okay? So the key thing to note here is that wherever you blow, wherever you apply a torque to the object, see, blew on my left side, so here, and it tilted this way, okay? But wherever you apply the torque, it's always going to be felt 90 degrees ahead, okay? So originally I blew here, 90 degrees ahead of that, the disc started to tilt, right? I also blew on this side, right here, 90 degrees ahead, it tilted this way. Okay, always keep that in mind. It always is going to tilt 90 degrees ahead of where it normally should, right? And at first that seems kind of confusing, but it's actually a little bit more intuitive than you think. So instead of using a disc, well, we're still going to use the disc, but we want to imagine it as just one little particle rotating around that pencil. So I'm just going to draw a little, oh geez, my pen's dead. I'm going to draw a little particle on there. That's our particle, okay? Now, if we follow this particle's path, we follow this particle's path around the disc, like so, and it's spinning around, right? If I apply, here, how am I going to do this? All right. Actually, it's going to be down here, okay? Now, if I apply a if I apply a torque on this side, it's going to go down, right? However, if this disc is spinning, instead of going straight down, right? If it's spinning, it's going to go down and over like this, 90 degrees ahead. Okay? So normally if I tap it there, it's going to be fine. But if it's spinning, right, it's not just going to immediately teleport down, right? Because that's going to violate the laws of physics. You can't go faster than the speed of light. This little particle can't teleport straight down. It's going to feel that force right here, but it's going to travel down as it goes forward. So we'll get a tilt right here, 90 degrees ahead of where I put the force, of where I put the torque, okay? And this is how gyroscopes work. And this is really why objects that spin are a lot more stable than when they're not spinning, okay? So, right, if I were to do this gyroscope again, we'd see it process around in a circle. Okay, now let me do it one more time, just for fun. And I can even balance it on this thing. At least I hope I can. There we go. And then we see it start to slightly process around like this. Okay. I actually did a pretty good job with this. It's taken a while to really, there we go. All right. So, you know, if I were to just let go and it wasn't spinning, it'd just fall straight over. Right? The reason why this is that I'm human. I make mistakes, or I make happy accidents. Okay. I'm not always... I just noticed that little thing right there from the... I think it's from Sesame Street or something. It's pretty cool. Where was I? I forget. Okay. But yeah, I'm human. I'm not perfect. If I place this, it's not going to be perfectly balanced, right? It's really hard to balance something with such a small base, such as this, right? So when you pull the cord and it starts spinning, and you place it down, you still place it slightly off center, like this. And what that causes is that gravity now is applying a torque to this thing. And again, because it's spinning, it's not going to go straight down. It's going to rotate 90 degrees. Okay? Now, it's feeling a force forward. Okay? Because it's feeling that force forward, it's going to now look like this. And now it's feeling the force over here. It's going to go 90 degrees ahead, like this. And this process is just going to repeat over and over again. So instead of just falling straight over, it's basically continuously falling all around, like this. Okay. So that's another demonstration of that sort of like 90-degree rule. Okay, and this actually has a cool everyday application, right? So if you remember, when you were a kid, and you were learning how to ride a bike, it was very intimidating because you didn't want to fall, right, and hurt yourself. So you'd always go slow when trying to learn when they were when you know the training wheels were taken off, right? If you had them. You always wanted to go slow, but that wasn't the best way to do it, right? It was always to try and go fast because the bike was more stable when you were going at a higher velocity, okay? That's because you had those wheels. Those wheels are spinning. They're basically giant gyroscopes, okay? So if you start to tilt as it's spinning, it's going to kind of correct itself. Okay, so that's why bikes and also motorcycles or unicycles are a lot more stable when the wheels are spinning and you're going pretty fast. Okay, now to demonstrate that even more, I actually took one of these babies from the school recently. Right, I'm gonna return it. Don't worry. It was in there before, right? It was meant for physics demonstrations. I didn't just I don't know, take this from the bike rack or whatever. Okay, this was in my room. I believe I should be able to take it back, take it here, and then I'm gonna bring it back. I promise. All right. But this is probably one of my favorite demonstrations to do in class, and I'm really sad that I can't do it now. But I'm gonna do it at home. Okay, so what I'm going to do is I'm going to give this bike wheel a healthy spin. And already we see it starts to process. I'm not, I'm not spinning this thing. It is, I spun it like this, but I didn't cause it to rotate, right? I'm not actively pushing it that way. It's just doing it on its own. Again, because it's just like a giant gyroscope. If I'm spinning it, let's say I'm spinning it so that the front part rotates towards you. Okay? So, like this. Now, just imagine that it's spinning. It's kind of, I can't really concentrate when it is. Okay, let's say it's spinning towards you, like so. All right, if I'm going to apply a torque to it, like this, or push it like this, it's not going to go that way, right? It's going to feel it 90 degrees ahead. So if I push like this, the wheel is actually going to go this way. Okay, now imagine that it's still spinning towards you. Okay, I can apply a torque this way as well. Now applying a torque like this is the same, right? This way is the same as applying a torque like this. Okay? If I apply, actually, hold on. Oh, never mind. Disregard that. Okay, so if I'm applying a torque like this, so to my left, like that, again, it's going to be experienced 90 degrees ahead. So the wheel will then be pulled this way. Alright, so you might have seen this online before, but I think this is great. So wait, and I don't have the best chair to do this, but we're going to give it a try. So again, I'm going to give this bike wheel healthy spin, just really get it going, and hopefully not break my fingers, and then sit in my office chair, and then spin. Look at that. And then, if I change the direction of the tilt, go in the opposite direction. Look at that. That is so cool. Okay. Alright, so I'm going to slow it down a bit. So that time, I was spinning it so that it was actually going toward, the top was going towards me, which is the opposite of what we did, the opposite of what I did before, right? So that's why when I turned it this way, I actually went, oops. Okay, that's because when I turned it this way, I actually went that way. All right, but now if I spin it towards you, if I turn it this way, I will also spin this way. All right, so let's give it a try. I'm gonna sit back a bit so you know that I'm not just controlling it with my legs. Alright, you still can't see the, oh well, you're just gonna have to trust me. Anyways, again, I'm gonna spin it towards you guys. Oh, that didn't work very well. How am I gonna do this? Like this, I guess. Healthy spin, and then let's go. Ready? To the left, I turn to the left. Tilt it to the right, I turn to the right. Isn't that fascinating? Now, if I were to get this to spin even faster, we'd see a greater effect, right? But because I'm only one person, that's what we get. Now, if you have a bike wheel with these very convenient handles at home, maybe you can do it too. Okay. But actually, this is I believe this is a specially made physics one, because the tires aren't exactly tires. They are, instead of being hollow rubber, they're solid rubber. That's to give it a little bit more momentum. Where were we? There's one more thing I'd like to show you guys. Okay, so what I'm going to do is just the gyroscope one more time. I'm actually going to take this string and hang it so the gyroscope is on its side. Now what that's going to do is it's going to produce a torque on the gyroscope. Because it's producing a torque on a spinning object, it will cause it to precess 90 degrees. So we'll see something that looks like that I'm defying physics, but I'm actually not. I don't know. Can I just sit down? I don't know. All right, let's give it a shot. And look at there. Physics in action. Isn't that amazing? Now, time for the grand finale. I'm going to take this thing off its stand. Alright. Okay. Now I can actually do this on an even bigger scale with the bike wheel. You guessed it, right? So I don't have a large rope to tie it to. Okay. But what I can do is sort of hold it with my hand, and you'll see it start to spin around. Ready? Watch this. Again, that's not me spinning it. That's just torque out and circular motion. Well, catch you guys later. Goodbye.